Okay, so continuing with the polynomial and rational inequalities. So we just got done doing quadratics, which means we had power of two. We're going to go beyond that. We're going to do higher ordered polynomials now with the inequalities. And so once again, I have an example here, and I do have the picture, but we won't always have the picture. But the rules basically kind of are going to stay the same. You're going to want to find the x-intercepts, and then once you find them, you need to test between them and beyond them to see, are my results coming back positive or negative, or basically what we're looking for here in this particular case, we want the results to come back less than or equal to zero. So the results are the y values, right? So you're going to plug in x and you get y in return, and those y values need to be less than or equal to zero. So we're going to be looking at this part, and this part is going to be my solution. But like I said, we're not always going to have the picture, so let's go ahead and follow those steps that I outlined in the previous examples. So first thing you got to do is find the x-intercepts. And so in this case, I have four terms, so most likely factor by grouping should work for us. And so let's see, I can start by factoring out an x squared here, and that will leave me with x plus 1. And then here I'm going to pull out a negative 4, and that will also leave me with an x plus 1, which is ideal because now I can factor out that x plus 1. So now that's what I'm going to do. I'm going to take the x plus 1 and factor this out. And then I'm going to be left behind with x squared minus 4. And then that x squared minus 4 can get factored. And then we're going to see that's where I get my 3x intercepts that we see from the graph up above. Okay, so now I've factored this completely. And so my x-intercepts are going to be -1, -2, and +2. And you can see those are all the ones that were listed on my graph right here. So we're going to do the same thing we did on the previous examples, but now we're going to have, let's see, we're going to have -1, -2, and +2. I'm actually going to give a little bit more space, actually. So I'm going to put -1 over here, -2 here, and, oh, I'm sorry, I got those backwards. Here we go, -2, then -1, and then we have a +2. Okay, there we go. Sorry about that. I was trying to get some more spacing because I'm actually going to have to test, I'm going to have to actually test four different places between -infinity and -2, -2 and -1, -1 and +2, and then between +2 and infinity. So I actually have four that I have to test this time. Now, once again, what I'm going to want to do here is probably use the factored form. That's going to be the easiest way to do this. And so I need to pick a value that's in this interval right here. So let's pick x equals -3 right here. And so I have to go ahead and plug that in for everywhere I see x, and then multiply that together and see if it's true or false. And real quick, before I do that though, what about my x-intercepts? Are they part of my solutions? If I plug these values in, -1, -2, or 2, it's going to make this equal 0. That's what we mean by x-intercepts, by solutions, by my zeros. It's going to make this 0. Well, 0 is less than or equal to 0. That is true. So what that means is I actually need to go ahead and fill these in because we are going to include these. These are all three of those points are part of my solution set. Okay, now I'm ready to plug in -3. So I'm going to -3 plus 1 is -2. -3 plus 2 is -1. -3 minus 2 is a -5. And then is that less than or equal to 0? Well, if you multiply it all together, it's going to end up giving you -10, which is less than or equal to 0. That's going to come back as true. So we're going to shade towards infinity right there. And I'll go ahead and add that to my interval notation. So from -infinity to -2. Now this time I'm going to bracket that in because I do get to include the -2. Now I need to try something here, and unfortunately, yes, it's going to be a fraction or a decimal. I'll probably use a decimal. X equals negative 1.5. And if you really want to, you could use a calculator, but I'm going to kind of show you how to do this where really you can kind of figure out by the signs of what's going to happen here. So let's see, negative 1.5 plus a positive 1 would turn that to negative zero point 0.5, right? And then negative 1.5 plus 2 would be a positive zero point 0.5. And then let's see, negative 1.5 take away 2 would be negative 3.5. And so we're trying to figure out, is this less than or equal to 0, right? Well, what we know here is that a negative times a positive is going to be a positive, right? And then I have a positive times a negative, which will give me a negative number, right? I'm going to have a negative value right here. Our negative numbers going to be um, less than or equal. Oh, I'm sorry. Got a negative right here. Sorry, I was about to give y'all the wrong answer. So right here, I'm sorry. A negative times a positive is negative, and then a negative times a negative is positive. There we go. So our positive numbers less than or equal to 0. No, positive numbers are not less than 0, and they're not equal to 0. So this is going to come back as false. Now, if you really want to, like I said, you could use a calculator and multiply that together. But like I said right here, you could just kind of look at the signs. And actually, a lot of books kind of explain it that way. They don't even really have you multiply them together. They just have you think, okay, negative and positive gives me a negative. Negative and negative give me a positive. And then from there, you can determine, okay, is a positive value less than or equal to 0 and go from there. Okay, so it comes back false. Don't want to shade there. Then we need to test something between negative 1 and positive 2. So let's go with 0. 0 is always a good one to plug in. So if you plug in 0 in all three spots, you're going to get 1 times 2 times negative 2. Is that less than or equal to 0? So when you multiply that all together, you get negative 4 is less than or equal to 0. That is true. That is true. So we'll go ahead and shade here. And so we want to go ahead and union that in. So we're going to union from negative 1 to positive 2, and we want brackets on both ends right there. All right, the last one we'll try, we'll go for x is equal to 3. So if I plug in a 3, 3 plus 1 is 4, 3 plus 2 is 5, and then 3 minus 2 is 1. Is this less than or equal to 0? Well, when you multiply that together, it's 20. Is 20 less than or equal to 0? 20 is less than or equal to 0. That would be false. 20 is greater than 0. So that's going to be false. And so once again, we did see that pattern kind of hold up. It went true, false, true, false. But once again, you can't always assume that that will be the case. And we'll probably see an example like that, I think, on this next one where maybe that pattern is going to be broken. Okay, so on this example here, we have to first set one side to 0. So I'm going to subtract 9x squared from both sides. That would probably be the easiest thing to do to get started. So we're going to have x cubed minus 9x squared is greater than or equal to 0. And let's see, here, let's see, what can I factor out? I can factor out an x squared. And then I'm left with an x minus 9 is greater than or equal to 0. And then so my x-intercepts are going to be at 0 and at positive 9. Those are the two values that will satisfy that equation, or not satisfy the equation, but give me a 0 in return. So this expression, if I plug in 0 or 9, it will go to 0. So then the question is 0 greater than or equal to 0? Which is true. So those two x-intercepts will be included. So let's see. I'm going to put 0 about right here, and I'm going to put 9 about right here. So 0 and 9. And so now we need to test some points here. And so negative infinity, positive infinity. Now remember, we said they are included, so I'm going to go ahead and fill these in right here. All right. And then now we just need to come up with some values to test here. So I only have three sub intervals. I have a sub interval here, in the middle, and then beyond to the right. So here, I'm just going to try x equals -1 and see what happens. And so plug it into both spots here and here. Use this for testing. So let's see, we're going to have -1 squared times -1 minus 9, which would be -10. Is that greater than or equal to 0? Well, when you square a -1, it becomes +1, and then we're going to multiply it by -10. So we're going to end up with -10 is greater than or equal to 0. Is -10 greater than 0? No. Is it equal to? No. So that's going to be false. So we do not want to shade to the left here because -1 is not included. Okay, what about, let's see, I can't use 0, so let's use +1. Let's use x equals +1 and see what happens here. So if I plug in +1, I'm going to get 1 squared. 1 minus 9 is -8. And then we want to ask ourselves, is that greater than or equal to 0? Well, 1 squared is 1, then times -8. So that's going to stay -8 is greater than or equal to 0. Same problem as the last one. Negative numbers are not greater than 0, and it's not equal to 0, so that's going to be false again. So that's kind of interesting. So we broke that pattern. We've got a false, false. Let's see about the last one. So we need to test something over here. Let's test like 10. Okay, so we're going to have 10 to the power of 2 times 10 take away 9 is 1. Is this greater than or equal to 0? Well, let's see. 10 squared is 100. 100 times 1 is going to be 100. 100 is greater than or equal to 0. Yeah, 100 is greater than 0, so that's going to be true. Okay, so the way we're going to write our solution, you do need to include 0 because 0 was a value that comes back true. So I'm going to have to do 0 and then union and then put the interval set in, which is going to be from 9 to infinity like that. Okay. All right, I think I have one more like this. So let's go ahead and take a look. All right, so this one's kind of similar, where you need to set aside to 0. Now, I really don't like this being negative. So I'm going to add x cubed to both sides to kind of get the left side equal to 0, or let the left side to be 0. So 0 is less than x cubed minus 6x squared minus 40x. Okay, so I did that. And then you can leave it like this if you want. Yeah, it's fine. We can just leave it like this. When I test it, it might be a little weird having it backwards. So if you want to switch the two sides, you can. Maybe I will go ahead and do that. But what you have to do here is if you're going to put this on the left side, that inequality is going to go from being less than to greater than 0. Because see, it says 0 is less than so-and-so, right? This is what this says if you read it from left to right. 0 is less than, and so on. So you need to be able to read these inequality symbols both directions. So even though we say this is a less than, you could also read it as, this expression is greater than 0. So just kind of be aware of that. So if you want to switch the two sides, just be sure to reverse the direction right there. Now we're ready to factor this. So what I notice is I can factor out an x to get started, and I'm left with x squared minus 6x minus 40. It's greater than 0. And then I can factor this right here. And so let's see, what's that going to factor into? I believe a minus 10 and a plus 4, right? So negative 10 times 4 is negative 40. Those two numbers would add to give me that minus 6 right there. And so my x-intercepts for this one are going to be 0 10, and -4. Okay, the hardest part I feel is done. Now you just have to set up your number line and do your test. So let's see, we got to put -4 first. So I'm going to put -4 here. Then I need to have 0. We'll put 0 here and then put 10 over here. And I didn't space it out perfectly, but I want to have enough room to do my testing. So here we are. All right, so we need to test something over here, something over here. Real quick, my x-intercepts are not part of my solution, because if you plug them in, you would get 0 is greater than 0, which is false. So they're going to be open circles right here. We do not include those. All right, so over here, let's test x equals -5 and see what happens. So plug it in to the factored form down here. Just plug it in. So let's see, the first term would be -5. Then the second factor would be, looks like -15. And then the third factor would be a -1. And so the question is that greater than 0? Well, when you multiply that all together, it's going to come back as -75, which is not greater than 0. So that's going to be false. So we don't want to shade this region right here. Next, let's pick something between -4 and 0. I like to keep my numbers somewhat, you could use -3 if you want, but I want to keep my numbers small, so I'm going to use -1. So let's see, the first factor would be -1, the second one would be -11, and the third one would be 3. Is that greater than 0? Well, when you multiply it together, it's 33, and 33 is greater than 0, so that is true. So we're going to go ahead and shade everything between right there. All right, let's try another one. Let's try +1. X is equal to +1. So let's see, the first value would be a 1, second one would be a -9, and the third one would be a 5. Is that greater than 0? Well, when it all gets multiplied together, you get -45 is greater than 0. -45 greater than 0. Nope, that's not true. That's false. Okay, and so we don't shade there. So then we've got one more we need to try. Let's go ahead and try if x were 11. So let's see, the first factor would be 11, then 11 minus 10 is 1, and then 11 plus 4 is 15. And is that greater than 0? Well, yes, because they're all positives, and so when you multiply them together, you're going to get a positive result. It's going to be what, 165, I believe. And so yes, that is greater than 0. That's true. So we want to go ahead and shade from here and beyond. So then when we write our interval notation, we want to go from left to right. So it's going to be parentheses 4 to 0, and then union from 10 to infinity right there. Okay, so that's kind of our higher order polynomials with the inequalities. The last part we need to look at is going to be the rational inequalities, and we'll start a new video for that.